If I were to add up the perimeter of this rectangle and the perimeter of the semicircle here, including the diameter, it is going to give me d, which means that x and x, 2x, plus y and y, 2y, this is going to be the perimeter of the rectangle, plus the semicircle's circumference, which is half of 2 pi r, so half of 2 pi x, plus the diameter is x plus x, so it is 2x. This is equal to d. I'm going to try to make y the subject. So 2x plus 2y plus this is pi x plus 2x is equal to d. So 2y plus 4x plus pi x is equal to d, which means that y is going to be d minus away this, which is 4 plus pi of x divided by 2. And what we are looking for is to maximize the total area of these two shapes. I'm going to call the total area A, and the area of the rectangle is x times y, and the area of this semicircle is half pi r squared, so half pi x squared. And the reason why we have done this is so that I can replace this y here with x, so that A can be expressed in terms of purely just one unknown, which is x. So this is going to be x multiplied by y, which is d minus 4 plus pi x divided by 2 plus half pi x squared. So if I were to expand this times this, it is going to be half dx. This times this, if I were to expand this also, it is going to be minus 2x squared. And this is going to be minus half pi x squared plus half pi x squared. So A is going to be equal to half dx minus 2x squared. And what we're going to do is to find the value of x that cause A to be stationary, and that will be when dA dx is equal to 0. So let's try to find what is dA dx, and that is half d minus 4x. And like what we were saying, we are going to let dA dx be equal to 0 so that we can find out the value of x that's going to cause A to be stationary. And that will be when half d minus 4x is equal to 0. Which means that x is going to be equal to 1 over 8 d. This is going to cause A to be stationary, and we want to check whether it is really going to cause A to be not just a stationary point, but it's a maximum point also. And to do that, I'm going to make use of the second derivative test. So I'm going to find out what is d squared A over dx squared. Differentiating this with respect to x, this is equal to minus 4, and this is less than 0. That is why I know that when x is equal to 1 over 8 d, A is going to be a maximum. And we are supposed to find what is the maximum value of A. So now we can find by substituting x is equal to 1 over 8 back into the expression of A. So it is 1 over 2d of x, which is 1 over 8d minus 2 of 1 over 8d squared. Substituting it back into here. And this will work out to be 1 over 32d squared. And comparing this to what the question wants us to show, we know this portion here is going to be the k. So k is equal to 1 over 32.